This is Mark Kemper with EMS, and this is the new Peel 3 3D scanner. All right, to get started with this video, let's talk about what we want to try to accomplish here. So the first thing we'll do is we'll take a look at the features of the new Peel 3 3D scanner. Secondly, we'll look at the different available options you can purchase with this scanner. Then we'll get in and talk about some of the applications, what this scanner is good for, kind of who the intended user is for the new Peel 3. Then we'll get into a demo. We'll scan a couple different parts and show how it actually works. Then we'll do our accuracy test. This is the kind of the standard test we do with most of our scanners. Let's see how accurate this thing is. We'll also do a feature test. That's a plate with holes in it. We'll scan different size holes, see how small of a hole and feature we can resolve with this 3D scanner. And then we'll get into pricing a little bit and talk about that. And then we'll wrap this up. So hopefully this will give you a really good understanding of this 3D scanner and how it works and really what it's good for. All right, to get started, let's talk about some of the features of this scanner. Well, first off, this scanner is manufactured by Creaform. Creaform has been building handheld 3D scanners for over 20 years. They're really the leader in handheld 3D scanning technology. Second of all, this is manufactured in Canada. Creaform is based in Canada. This is manufactured up in Canada, which is a great thing. Also, this is an industrial professional scanner, designed and built from the ground up, brand new. This is not a consumer or a prosumer type scanner trying to be a professional 3D scanner. This is a professional industrial scanner. Now, some of the really neat features are this new LCD screen. And what's nice about this, it's a touch screen, so I can touch and do different things with it, and it's also upgradable. So if they add new features to the software or the hardware, they can update this LCD screen. So maybe depending on what I'm doing, different processes, I'll have different options on here. So this is really nice. It also will change colors, similar to some of the other Creaform scanners. If I'm too close or too far away or I lose position, this LCD screen will give me the color, and so will the computer screen. You can add this or put this lanyard on, which is really nice, so if it slips out of your hand, it doesn't fall to the ground and break. And you have this new ergonomic handle, which I really like because it lets you kind of hold it in a horizontal position, but then, a vertical position, but then also in a horizontal position. And I've been using this for a while, and I really like it, especially, leaning over and trying to scan different things. So, it's very ergonomical. And then the other thing is it has haptic feedback, because there's times you're scanning, you can't see the LCD, you can't see the computer screen, maybe you're trying to reach in somewhere and you're kind of far away from your computer and you're trying to scan. If this thing loses position or if you're too close or too far away, it'll actually it'll give you a slight little vibration. Very subtle, but you definitely feel it, and that's really nice, and it's already helped me out a few times as I'm scanning stuff and I can't see the screen. So that's kind of a nice nice feature. And then finally, not only is it a brand new scanner, but we've got some brand new software called peel.cad. And again, built from the ground up, and they've really simplified and streamlined the whole entire 3D scanning process. You'll see that here in the demo. It's simple, but yet powerful. We can get everything we need to get done, but it's just a really nice interface. If you've never done scanning before, I think you'll find this really nice and straightforward. So next, we'll talk about some of the different options available for this scanner. All right, so taking a look at some of the options available for the Peel 3D scanner. Now, when you purchase the scanner, this is the standard case. It's a foam case. It's nice. It's got the calibration plate, which we'll show later how to calibrate, integrated right into the lid. You've got storage in here for your cables, your targets, things like that. But you can upgrade to the hard case here, and this is going to be great if you're going to do any travel or you're going to ship this thing around. This is going to be a more sturdy case with a handle. It also comes with a strap. So if you're going to do any travel, this might be a great way to go to get this, this better case for the scanner. Also available is what's called a protection kit, and it's got a cover that goes over the front of the scanner here. It's got a skin that kind of goes around the front, so if you're in areas that are dirty or you're getting really close and you don't want to scratch up your scanner, it's also got some protective glass for the LCD. That is a nice option to get that protection kit if you want to add that. And then they've got a program called VI Peel. And what that does is that adds a second year of maintenance to the scanner. So it comes with a standard 1-year maintenance plan. So if anything goes wrong with it, it's covered. You send it in and they repair it and send it back. But with the VI Peel program, you get a second year of that plan with it. And then you also get accident coverage, okay? Accident coverage means if you drop it and break it, they will repair it. Now, there's a $200 deductible, but most of the time that's probably going to be a lot cheaper than having to foot the whole bill to repair it. So that's a nice feature to have. You also get discounts on targets and accessories. And then another great value is the trade-in program. So within the first year, if you purchase the VI Peel program, you want to upgrade to another Creaform 3D scanner. Maybe you've used this, you've really proven it out, you really like it, but maybe you've got higher accuracy needs, or you're going to do really large stuff, or whatever the case may be. You can get full value of what you paid for this scanner towards a higher end Creaform 3D scanner. So that's a great deal. So that's called VI Peel. And then there's an option called peel.cad. Now the standard peel.os that comes with it is great to scan, do some basic cleanup, do an alignment, and we're going to show all this. But all you're really doing when you're done is you're outputting an STL file. That's a polygon mesh, and again, we'll talk more about that. That is not a CAD file. That is not a step file or an IGES file or a 3D CAD model. So in order to do that, you need what's called reverse engineering software, and this has the option of built-in integrated reverse engineering software to take 3D scan data, build CAD entities, and then export those into a traditional CAD system where you can actually work with them and do whatever you're going to do to design your part. So that's called peel.cad. So that's a really nice feature. So you've got a lot of different nice options available to you, and so you can decide which ones are right for you. So those are some of the nice options you can get with the new Peel 3 3D scanner. All right, let's talk a little bit now about what are the applications. What is this scanner good for? Well, it's got really a lot of uses for this 3D scanner. But in general, any kind of general reverse engineering applications are what the scanner is going to be really good for. For example, patterns. Here's a piece of foam. This could be wood or foam or another material. Maybe it's been carved out by hand and now you want to scan it and get it into 3D CAD. It's great for that. Things like medical prosthesis, things like that also is a good fit. Aftermarket automotive, either performance parts or maybe add-on aerodynamic parts where you scan the car and then design pieces to fit on it, or you're scanning an existing, maybe an OEM part and making a new one for better performance characteristics. Art and sculpture, things like this. You can see the sculpture back here. Just really a lot of different things. Patterns for castings is another good one. Packaging is another great use for this stuff, like for the bottling industry or just packaging, because this scanner does scan in full color, which we'll show. Another thing is MRO, which is usually in like the aviation industry for maintenance and repair and overhaul. They've got old parts, they have no CAD for it, they want to scan it, and so forth. So it's a wide variety of applications, primarily around reverse engineering is what the intended market is for the Peel 3D scanner. All right, so we're ready to now actually get into some scanning here. Now the first thing we're going to do is we're going to calibrate the scanner, and let me explain what that is before we do it. The reason you want to calibrate the scanner is you really want to be able to adjust primarily for thermal expansion. If you, for example, store the scanner in an air-conditioned office at 70 degrees, and then you go out in your shop and it's 90 degrees and it's humid, you're going to get thermal expansion. It may be slight, but you will get expansion. That's going to physically change the size of the scanner. Now, how this scanner works is a process called triangulation. We're not going to get into a lot of detail here, but basically, if this thing swells or moves, even a slight amount, that's going to throw everything off from the factory, the way it was calibrated from the factory. So let's show you the calibration process, and basically you take this plate, it's integrated right into the lid of the scanner, you pull that out, you tell the software you're going to calibrate, and you're basically taking measurements at different heights and then different angles. And that plate is glass, and that glass is very thermally stable. So what you're doing is you're scanning that plate with these targets, and there's a calibration file from the factory that knows exactly where those targets should be, so that if that scanner has basically expanded slightly, we will measure against those targets, and then the software will compensate the difference that it measures from the original file from the factory when it was calibrated. So calibration is important, and I've seen some of these lower-end scanners that claim they don't need any calibration, and to me that just screams right away it's inaccurate. You absolutely have to calibrate, and you should do it really every time, every day that you're going to use it, or anytime your environment changes, okay? So the software will prompt you to calibrate. It literally takes a minute to do, and then you calibrate and you're ready to go. All right, so to get ready for the demo, this is a bell housing, automotive bell housing. Now I want to point out in the description below, we're going to have links to all of these files that we scan, and maybe some other files that we'll throw up there. And then also, we'll have links to some of the other really helpful videos. We have over 100 videos on our YouTube channel now, and one of them will be the tips and tricks video. Now, this was for the Creaform scanners, but this scanner is just like it. You can almost think of the Peel 3 as the junior GoScan Spark scanner. A lot of the technology that's in that scanner is now been adopted in the new Peel 3 3D scanner. So I encourage you to check out some of those videos that'll go into more detail on a few of these tricks I'm doing. But to start with, if you've seen any of our videos, you know we use these. These are little triangles. You can buy them at Lowe's or Home Depot. We put targets on them. And we use these for two things. One, we use them to get the part off the table. And you'll see why once we get into this, because when we do the scanning later, I'm going to need to be able to separate the table from the scan data, okay? And then we just also will put them around. We don't really need them in this case, but they're great. When the scanner is scanning, and we'll talk about targets and everything here in a minute, this will help as we lean over, okay? So let's talk about scanning with this scanner. Now, targeting versus not using targets. This scanner will work with no targets. If there's not targets on the part, it will work. However, if the part is very nondescript, meaning there's not a lot of features to it, this scanner and any scanner that doesn't use targets will have a hard time, because that's called geometry-based alignment. And what that does is the scanner samples the shape in 3D, and as you're moving along, you're taking a sample, and you're lining them up. Well, think of going down a flat wall where there's nothing unique from scan 1 to scan 2 to scan 3. And when I mean each scan is it's sampling, right? There's a refresh rate. It's pulsing out the scanner, the lines, which we'll show here. So there's nothing to line them up, and that data is going to slide all over the place. What the targets are, these are 6mm reflective targets. They're called retroreflective targets, okay? And then they have a black contrast around them. That just helps the scanner see them a little better. And by having at least 3 in the view of the scanner will lock on and position using those, okay? So think of GPS. The targets are the satellites up in the sky, and the scanner is the receiver. And it's a process called triangulation, just like the same process to figure out the 3D shape, which we'll get to. So by seeing those targets, it can lock on. Those targets are only for positioning, okay? More targets is not going to make it more accurate. It's either going to be able to position itself or it's not. And if it gets really lost, it's just not going to scan, or you're going to get bad data. So the targets either need to be on the part or around the part or both, okay? And we're going to show both. This is a hybrid. We've got targets on our Lazy Susan. We use this a lot, again, in our tips and tricks video, because this lets me scan and rotate. So I've got targets on. These targets can be magnetic. They're sticky. We've got a product called Speed Target, which is tape. They're on basically a clear tape. So if you're doing larger objects, you put this tape on. It's very fast. It peels off, and it's also reusable. So there's plenty of ways to target. Smaller parts, we tend to just have them on the table, or in this case, we have them on both. So let's get started. So we've got targets. We've got our part off the table. We're ready to scan. Now here in the new peel.os, what's nice is they've really simplified this interface. So we pick the part size. So for example, tiny, small, there's a description, medium, etc. I'm going to put this in the category of small. And then what detail? This gets into your resolution. Now for somebody just starting out, they don't know 0.1 millimeter from 2 millimeters or 30 thousandths of an inch from 125. They just may not know or what's good for a part like this. You can see here the default is fine. We can make it normal, we can make it coarse. Now keep in mind, we can always go back and update this later. I'll explain that in a minute. And then how do we want our output? I'm not going to get into all these right now, but basically letting the software at the end help you process the data. Do you want it to smooth it? Do you want it to fill in holes? Do you want it to sharpen the edges? Things like that. And again, instead of having to go and click a whole bunch of buttons and try to figure it out, you just click one of these 4 options. For example, Express is going to do minimal processing, and it's going to make the process fast. Okay, Watertight is going to try to close the whole thing up. Balanced is a little bit of everything, okay, or Enhanced is going to sharpen and smooth things out, okay? And then do you want color or no color? I'm going to start with no color so we can get going here, okay? Then I just hit the next button, and we're actually ready to scan, okay? So we pick up our scanner. On our LCD panel, we just hit the play or start button, and we start scanning, okay? Now, let me talk as we go along here. The scanner is picking up the shape of the part. It's projecting out lines. This is an infrared light or light source, so you actually don't see the lines on the part. But you can see the area it's scanning, and part of how big the area it's scanning is in those options, how big of a part I told it I'm scanning. So it's finding those targets and using them for position, and then it's projecting out those lines, and then the cameras, the sensors on here, are picking up that 3D shape, okay? Now, you can see green here as I scan, and I've got green on my LCD. You can see when I get too close, it turns red, and I can feel those haptics, and when I get too far away, it turns blue, and again, I can feel those haptics, okay? So you just want to basically keep it in the green zone. And as you've probably heard me say a million times, if you've seen any of our other videos, it's digital spray painting, okay? You want to hold it somewhat perpendicular to the surface you're trying to scan, and you just kind of move around, okay? So the more perpendicular, the more data you can get, just like spray painting, okay? You want to be kind of normal to that surface, okay? So you just keep moving around. You often hear me say also you can't overscan it, meaning you can go over and over and over the same areas. It's not going to hurt it. You can certainly underscan it, right, where you don't get enough data. And there's no magic button that says, hey, you've got everything. You were going to stop and take a look at the data, and then we can go on. So speaking of, let's say we think we're done. I can hit the pause button here. I can set the scanner down. It's got some rubber feet on the side of it. And I can zoom in and rotate and look at my data and decide, oh, gee, I missed an area over here. And I just go back, I push the button, and I start scanning again, okay? So it's, at the end of the day, it's up to the user to, be able to scan, everything you need. And you only have to scan what you need. If there's areas of this part you don't care about, you don't necessarily have to scan them, okay? So we move around, we get everything we think we need. And I'm not going to spend a ton of time on this, but this is enough for the demo. Okay? Holes, as holes get smaller, that's where you'll spend more time. So once I think I'm done, I hit the next button, and it's going to walk me to the next step. And this is a clipping plane. This is in the other Creaform scanners, you'd have to go and say clipping plane. This automatically brings it on, because almost always with parts like this, you're scanning on a table. And what it does is it finds the lowest flat area and builds a plane. But then I can grab this little arrow and I can slide it up, and you can see it's going to clip off everything in red. and I can hit continue, okay? So that's a quick way to get rid of a lot of junk. But you can see, when I say junk, just things around the part we don't necessarily want. That's also why I lift the part off the table, so I get a nice clean edge or definition to my part. I don't have to worry about that clipping plane maybe clipping off part of my scan data I want to keep. And then we've got some options here to select data, okay? And this one is the select everything connected, right? So you see me click on there, and everything connected where I click gets selected, which is what I'm going to want to keep, right? So I will just now come over here and say keep only and hit continue, okay? Now, if I was done scanning, I can go to the next step and start processing. But this part, as with many parts, have two sides to them. I mean, unless you're scanning a ball or a statue, even that, usually there's a bottom on it. I need to scan the inside of this bell housing. So how do I do that? Well, if I move the part now, because I have targets on the table and on the part, if I flip it over, that relationship's all messed up. So I'm going to want to do a new scan and then put those scans together. So we'll go ahead and let's go ahead and do it first. We'll tell it we're going to add a new scan, and it's going to save our session for us, just so we have it. And I'm going to flip the part over. Okay. And as soon as it gets done setting up, we'll be able to continue on and start our next scan. And you can do as many of these as you want. So we're ready to scan. We can go ahead and hit the button on the scanner, okay, and start scanning. And just like before, it's digital spray painting, and we just work it's all line of sight, okay? So, you know, some of these holes and features, you're going to move around them and really get in there and get, you know, good data, you know, take your time. And then we'll move down. Let's get the table all the way around. The nice thing about this, having this Lazy Susan, obviously, is I don't have to walk around the part, but it just makes moving around the part, because we have targets not only on the part, but on the table. It makes just getting around the part easier. And targets always make things faster. The scanner can scan faster. It's going to be more accurate. So targets are usually worth putting on, okay? You don't always need them. We're going to show a part later where we don't use any targets on the part. But if you can throw a few on, it's definitely worth it, okay? So again, I'm not going to spend, you know, time scanning every single feature on this. Good enough for the demo, okay? So now we're done scanning. We do that same thing. Let's go to the next step. Pretty much like last time. We can move this up. And theoretically, we don't even have to use this clipping plane. In fact, let's just cancel it. I'm going to just grab here. Well, no, I guess I do need it because it looks like our triangles are connected. So let's go back to it. And even though it's automated, I can still go ahead and grab things. So for example, I'm going to grab that, move it up close to the bottom, and go ahead and hit continue. That's going to get rid of most of it for us. And now I'll use that connect command again, and we'll keep just that, okay? But what you're going to notice is there's probably one of the triangles, yeah, right there. It is connected, probably when I leaned over. So this is great because I can actually show some of these other editing tools, one being the lasso. And I'm just going to come in here and just lasso it, right? So I've selected that, and this time I'm going to say delete, okay? So that'll get rid of that. So you can use some of these different selection tools to select and either keep or delete your data. Okay, and along the top here you can see we've set our parameters, we did our scanning, and now we're in the cleanup, and next we're going to hit the next command, and we're going to go to the merge. Now what's really nice is it's already done. So the merge command will look at your part and try to match up targets. So we had targets on the side here when we scanned it on the other, when we had it flipped over. And then when I flipped it and scanned this side, I also scanned out here. So it can line up those targets for us automatically. Now, if it can't do that because you're not using targets, it'll try to auto-align it, and then you can also pick some common points and do it. Okay, so, but you can see here another advantage of using targets is it's already found how they align because it found matching targets, and now it's merging those two data sets together for us. So you can see within 5 minutes we've got this scan. Now to do a really good job, Probably take another 3 or 4 minutes per side to really get in and get all the features. But again, you can see how simple this was to scan this automotive bell housing. And as soon as it gets done merging, it always saves too as you go along, just in case something happens, you lose power or something, you'd have what we call a session file to go back to. And as long as you save these session files, you can open them up later and make changes. Remember, I had set it to fine. Well, maybe I want very fine resolution, or maybe I want to go back and clean up the data some more or something. You can always do that. So now it's doing what's called the finalize. It's taking all the data, it's processing it. I think we had picked enhanced was our setting there. That's where we want to smooth or sharpen corners or fill in holes, or whatever we want to do. It's taking care of that for us right now. So we've got it all cleaned up, and you can see we can come in here and take a look at it, and you can see, it looks really nice looking data there. Look at the detail. We can pick up the text on here, really nice. But the problem with 3D scanners is they have no coordinate system. When you start scanning, it doesn't know anything from anything. So right here in the software, it asks me, hey, do you want to do an alignment? And I'm going to do that. So what I'm going to do is I come up here and I'm going to say, I'm going to set the XY plane. It automatically defaults to a planar entity. And if I just click on something that looks like a plane, it's going to look at that scan data, fit a plane through it, and then you can see it's aligned my X and Y coordinates to be parallel to that plane. And I could set an XZ or a YZ as well, but since this part is round and I don't have any other planes and I really don't care, so I've locked it in this way, okay, and I've not locked it in this way in this case just because I don't need to. But you can lock it into all 3 coordinates and put it in exactly the coordinate system you want. I'm going to click the lock button. It is now set, and then I go to my next step. Okay? So now I'm ready to improve it. If I want to go in and do additional smoothing, hole filling, we've got a bunch of stuff over here we can do. We can decimate, we can clean up edges, just some nice tools. This is all with the polygon mesh. Okay? This is just a polygon mesh, which you could kind of think of points. It's just STL data at this point. I'm going to say, no, I like this, it looks good, and so I'm going to go ahead and export. I'm going to right now just export it as a mesh. I'll talk about peel.cad later. And we're going to call this bell housing 2. So that's going to save an STL file and a session file. And again, an STL file is just a mesh. Okay? It's a polygon mesh. It is not a CAD file. That's where we would go into the peel.cad. We're going to do that in a separate demo where we'll scan a part and take it in and actually build CAD. But for now, we're just going to export an STL or a mesh file, polygon file, whatever you want to call it, which is typically STL, or if you're doing color, it's OBJ. So that's just a quick little demo of how fast and how easy this scanner is. Within a handful of minutes, we've scanned the part, we've cleaned it up, we've put it in a coordinate system, we've merged 2 scans and exported it. And from there, we can typically are going to take that into some reverse engineering software. All right, next up, let's take a look at a smaller part. So I've got this little valve here. It's got some really fine holes, some small fine features. Let's see how the scanner does on something like this. So in this case, I'm going to come over here to the software. I'm going to tell it the part is tiny and it says smaller than 200 millimeters. I want very fine detail, and I could go watertight or express. I'll go ahead and do enhanced. Watertight's going to try to close it all up, and I don't need color for this, and we'll hit go. Now, in this case, I have targets on the table, but no targets on my part. Just on small parts like this, it just needs to have targets in its field of view. They don't have to be on the part. So I'll go ahead and hit start. And what you'll notice right away is the scanning volume, or the area it's scanning, is smaller. And that's based on the part size we told it. So again, I don't have to try to figure it out. I just tell the software, what the size of my part is, and it'll figure it out for me, and then I just move around and scan it. So like the bell housing, I'll scan this, I'll flip it over, I'll scan it, I'll align it, and then we'll come back and take a look at the results. But the process is the same. So we'll go through, I'll take my time, get this data, and then we'll go ahead and take a look at the results. All right, next up, let's do some color 3D scanning. Now, why would you want to scan in color? Well, there's a lot of reasons, especially in the packaging industry or VR environments, animation, things like that. As these scanners get better and have the ability to scan in color, you can actually scan things and immediately take those into an animation or use them for product marketing, all kinds of stuff. We actually have a separate video where we actually scan a child's toy that's a whole bunch of different colors, and we show how we can animate it, because in the world of animation, they usually have to build CAD out of everything. Well, if we can just scan it and then use that digital asset in a VR environment, it's really powerful. So whether it's something like this bottle or maybe this helmet, it's really nice. So again, it could be product development, could be art and entertainment, could be packaging, could be a lot of things. But anyways, so we're back in the software here, the peel.os. We've picked small part, fine detail, and on a part like this, we might even be able to get away with normal detail. It's not super intricate. We'll use enhanced again, and this time we'll click color and we hit go. Okay. So again, what's nice about this software is you don't have to be a scanning expert that's done this for 20 years that knows, yeah, I need this resolution and this, and those kind of things. This will figure it out for you, okay? So again, we'll use our targeted table, but you're going to notice no targets on the bottle. It will fill them in with color, but it's always better if you can get away with not doing it. So we'll hit the scan button, and again, I'm going to go around and pick up the targets on the table first, okay? That way it knows where they all are. But then we're just going to move up, and you can see we're scanning in full color, okay? And we'll just move around. And the trick here is just taking your time. People want to go way too fast, especially when you're not using targets. Just go a nice steady pace, because it's trying to lock on with the geometry. And that takes a little bit more work with the software. And speaking of software, as far as computer specs, that's something we can give you, because they're always changing. But you do want a good computer, especially if you're doing color, with a good graphics card with a decent amount of memory on it. Basically, the larger the parts, the more complex your parts, or scanning in color, you definitely want to have a good computer to work with this. And the reason being is because as these scanners get faster and higher resolution, higher detail, better color quality, they just require more horsepower to process that data, because at the end of the day, it's just more data, okay? So you can see I'm moving around, I'm getting it. Again, it's all line of sight, okay? And then when we think we have it all, we'll stop and we'll take a look at it, okay? So we'll go ahead and stop, okay? And we'll zoom in. Now, while I'm here, we haven't done the final process yet, so it'll look okay. Once we do the final processing, it'll sharpen it up and clean it all up. Because we're kind of in this mode right now that allows us to take a look at it as we go, kind of this instant feedback mode. But you can see we've got some great color here, and we're done, and we can go ahead and process it just like we did the other one. All right, let's now take a look at a more challenging part. And what I've got here is a chrome wheel cover. And let's see if we can scan that with this scanner. Because this is what's called a structured light scanner, where it's emitting some kind of light pattern versus like laser or something else. And one of the challenges with these types of scanners is dark and shiny surfaces or direct sunlight. So let's see how it does on something like this. So we'll go in, we've got all of our standard settings we'll take here like we did before. But one of the things I can pick here on the LCD panel is what's called the shutter mode. And we can do light, meaning the part is a light color, dark, or automatic. Automatic shutter is just going to try to adjust. So what that means is it's going to adjust the power of the light. So if it's a very flat, light color, you don't need a lot of power. In fact, you would oversaturate it with too much light and you won't get data. And vice versa, with something like this, we need more power to try to get a return back to the sensors, and dark parts are going to absorb it, and shiny parts are going to refract it all over. So we're going to set it to that dark mode, and we're going to go ahead and start scanning. Okay, and let's see how it does. Okay, so you can see it's picking it up. Okay, but you know it's going to be a challenge, and then really how good is that data? What is the quality of it? Okay, so you can see in some areas it's really having a hard time picking it up. Okay, so I'm not going to spend a lot of time. So this is where any of these structured light scanners are going to have more of a challenge. Now the good news is there's some scanning sprays out there you can use, and some of the new ones actually disappear over time. They actually sublimate or evaporate out. So you spray them on, you can apply targets right over the top of it, and then there's different formulas that basically evaporate over time, and they leave nothing behind on the surface. So, you know, the one thing you'll have to consider with a scanner like this over, you know, the higher end expensive laser-based scanners is you might have to dust parts like this. Because if we come in and look at this data, you know, it's okay, but it's pretty rough. It's really going to have a challenge in some of those areas. So that's an area where you'd want to spray the part. You can also put wax or talc powder. There's lots of little tricks. But that's just something you got to be aware of. On parts like this, it's going to be more of a challenge, and that's where dusting or spraying something on it would be helpful.
Next up, we're going to do an accuracy test. And what's really important with any accuracy test is understanding how the test was done. For example, you could see an accuracy number, but that might be on a 4-inch gauge block doing a point-to-point comparison. Because you're scanning in a 3D world, you really need to look at a 3D volumetric accuracy test. And that's what we're doing here. We've got a 25-inch calibrated ball bar going left to right. We've got another one going back to front with some elevation. So what we're doing is going around and scanning them in this 3D volume, and then we're going to measure our scan results back to the actual calibrated ball bar numbers on the bars, and we're going to look at the difference. Again, you're scanning in a 3D world. You need to look at results in a 3D world, and that's a volumetric accuracy. That's a key thing you want to look at with any 3D scanner. So we did this 4 times with the 2 bars. And as you can see here, depending on the direction of the bar, we get different numbers. So what we do is we take all those numbers and we put them together and we average them. So in this 25-inch volume, we had an accuracy average of around 0.02 of an inch, which is very good when you consider the price point of this scanner. These results are really, really good in a 3D volumetric accuracy with the new Peel 3 3D scanner. So how small of a feature can we 3D scan with the new Peel 3D scanner? Well, we have this plate with holes and slots in it that we had made, starting at a 1/2 inch in size down to 60 thousandths or 0.060 of an inch. And what we do is we 3D scan it and just move around and do the best we can to scan all the slots and holes in this plate. And then we analyze the data and see at what size of the data is it still usable. How small of a hole can we resolve and it's still usable data. So we'll just work our way around this plate, doing a good job to scan it. Again, because it's line of sight, we're going to just want to hit it at a lot of different angles, especially on those smaller holes. And we'll take a look at the data and see how well the new Peel 3 can scan and down to what size is usable. All right, if we take the 3D scan data and we brought it into some reverse engineering software where we can analyze it, you can see on the larger 1/2 inch, 3/8, 1/4, 1/8 on down, data looks really good. You can see we're scanning all the way down in. This plate's a 1/2 inch thick, no problems there. As the holes and slots get smaller, you're going to get less and less data, meaning depth, down in there. But certainly even on most of these holes, we have plenty of depth to define those holes and slots. All the way down except to the 0.06. It's getting a little bit tough there on the hole. It's just not really resolved, and the slot's a little bit rough. But overall, not bad. Most hole sizes we're going to be able to get until we get down to about 0.06. Now, we cut a section through here as well, and let's take a look at that. And we ran the accuracy analyzer on it, and that's basically comparing our circle to the scan data. So we fit a perfect circle and slot, and everything looks good all the way down to about this 90 thou. Overall, it's good. It's still usable. We're starting to get a little bit of scatter data or incomplete data down in that hole, but certainly usable to define that hole. And again, the 60,000 is a little rough, but the slot's not bad. So overall, the Peel 3 did a really good job. And we've done this test also with all of the higher end Creaform 3D scanners. We'll put the link in the description below you if you want to compare this to those other scanners. You can check that out. But overall, it did really well.
All right, so this wraps up the video on the new Peel 3 3D scanner. And hopefully you found it interesting. Hopefully you were able to see the real value that this 3D scanner has. In this price range, there is nothing else that comes close. When you look at the quality of not only the equipment and some of the new features, but the software that comes with it, not only the Peel OS, but the optional peel.cad, which again we'll have a separate video on. You won't find another integrated reverse engineering software available. And it's from a company that's been in this business making handheld 3D scanners for over 20 years. And you know, if you go on Amazon or eBay and you buy some of these scanners, who are you going to call when you have problems or you're trying to figure something out? The advantage of working with a company like EMS, who's been selling Creaform for 16 years, we've been doing this for over 21 years as a business, we've seen just about everything. So when you have problems, it's not just about, well, what does this button do or that button? It's about technique and tips and tricks or how to model something really complex. And what we offer to our customers with the Peel 3 and all of our scanners is customized training. That can be web-based, that can be in person, that can be at our office, and really teaching you the tips and techniques and the ways to do modeling and other things, especially when you start getting into large things or complex geometry. We've also got our own bundles we've put together with the Peel 3, so we can bundle all of this up. We've got our speed target tape, which is great for large objects, and just all the things we've learned through the years. So hopefully you found this helpful. We'll put the pricing in the link below because it could change over time, but we'll try to keep that up to date. But again, value for the money. You will not find a better scanner in the, in the entry-level professional industrial world. This is just a great 3D scanner.